Welcome to another ZBD developer tutorial. This guide will walk you through integrating Google Play Integrity into your Unity game. By the end, you will have a more secure game environment and the ability to verify the authenticity of devices running your game. Before we dive into the implementation, let's understand what Google Play Integrity API offers. It's a suite of tools and services provided by Google to maintain the integrity and security of apps. These tools help detect and prevent unauthorized modification, protecting your game from potential threats. For further details, you can refer to the official documentation at this link. In this tutorial, our primary objective is to generate a token, making API calls, interpreting response. We will start by generating a token on the client side and transmit it to our server, which in this case is Beamable microservice. Then the microservice will initiate an API call to Google, retrieving the Play Integrity response. Based on this response, we'll make informed decisions about how to proceed within our game. Now, let's delve into the implementation step by step. Our first step is setting up our project on Google Play Console. Head over to the console and create or select your app project. We'll name ours App Integrity Test App. Head to the App Integrity section, click on Setting and link your project. Now the project is linked, go to Goal and click on Select Actions. Here we can specify the action we want to prevent, such as unauthorized access or in-game cheating. The select depends on your specific requirement. Once it's done, go to the Response section, click on Change Response, turn Play Protection Status on, and click Meet Basis Integrity and Meet Strong Integrity. You will observe a JSON response illustrating how the integrity check appears. In our Beamable microservice, when the ZBD template queries the Google Play Integrity API, it returns a response like this. When checking app integrity, if the app is recognized as Play recognized, it considers secure. However, when checking device integrity, there's 3 levels. We usually prioritize the most strong integrity level to ensure the device is genuine. This helps prevent common gaming platform attacks like using fake or modified devices. However, we still recommend it. Additionally, our ZBD template includes this feature to whitelist devices, allowing users to bypass check if needed. Remember to save your change once you are done. Another important step is to consider increasing the number of requests your app can make to the Play Integrity API. By default, you are limited to 10,000 requests per day. You can request an increase by filling out this form. First, please specify and select increase the maximum number of daily requests. Then, fill out your name and email address. Next, select My App is called in the API directory and choose the standard request. Click on once per hour. If you select once per 50 minutes, you will receive a notification that is not allowed because it's recommended to use Google Play Integrity less frequently. In the section regarding whether you are validating Google Play Integrity response, select Server Side by calling Play Server to decrypt and verify. Choose No Retry and select Deny Access to Functionality. The most important aspect is specifying how many estimated queries per day. It's recommended to go with this amount for now. However, if you start to notice that you are hitting the API limit, you can reapply. Feel free to fill out any more specific details here. Currently, since we are just testing, we don't need to do this. However, remember to increase the request limit once the app is no longer in the testing phase. Next, scroll down to the Store Listing Visibility section. Here, Google Play can verify if devices pass the integrity check before making them visible to users. Simply click on Turn On and select Device Integrity Check. Then save your change. Once you have completed all these steps in Google Play Console, you are ready to move forward. Now, let's set up Google Cloud. Go to the Google Cloud website and create a new project. You can name it anything you like. For example, I'm gonna name it My Test Game. Once the project is created, navigate to APIs and Service section and click on Enable APIs and Service. Scroll down to the Mobile section and select View All. Then choose Google Play Integrity API and click on Enable. In AIM and Admin section, go to the Service Accounts and click on Create Server Account. Give it a name such as Play Integrity Service Account and click Create and then Done. Click on the newly created account, navigate to Keys and click on Add New Key. Select JSON format and the key will be downloaded. This service account will have permission to query the Google Play Integrity API. Now, let's add Google Play Integrity package to Unity. Download the Google Play integration package from this website and import it into Unity. Wait for the import to finish. Make sure that Beamable and ZBD template integration into the project is completed, as demonstrated in the previous video. Go to the Beamable Content Manager. As you can see, we have already created these items. Proceed to the Microservice Manager and click on Play on the Game Service microservice to ensure its function correctly. Ensure also that the Docker is running properly. Following these steps, we'll set up Google Cloud, Google Play Console, and integrate the Google Play Integrity package into your Unity project, along with ensuring the functionality of Beamable microservice. Now, let's delve into the code. Navigate to ZBD Reward Game Object and locate the reward controller script attached to it. This script handles the generation and transmission of the token to our server for a response retrieval. On the client side, within the reward controller script, we create a method called StartPlay Integrity. The method initiates the integrity check process by starting a coroutine named Prepare Integrity Token coroutine. The StartPlay Integrity method takes two parameters: play hash, representing the payload hash, and callback, an action that handles the play integrity response object. Regarding the payload hash, let's explain what is hashing. Hashing is more like converting an input of any length into a fixed size string of text using a mathematical function. This means that any text, no matter how long, can be converted into an array of numbers and letters through an algorithm. In our case, we take game data and use a Unity built-in hash function such as getHashCode, which take the input data and generate a unique hash value based on its content. The hash function calculates this value in a way that even a small change in the input data produces a significantly different hash value. That's why it's important to hash the payload and send it within our StartPlay Integrity method, as we will later use it in our game server for detecting if the game data has been altered. Regarding the Prepare Integrity Token coroutine, it's prepare the integrity token, waits for its completion, checks for error, retrieve the token, and send it back via the provided callback function. Then, you can call the StartPlay Integrity method when needed. For example, in our case, we first verify the device using the should-verify method. We then call the StartPlay Integrity method, pass on the payload hash. Once we obtain the token, we can send it to the microservice responsible for the API's calls with that token to Google. In this case, we call the send-to-game-server method. Within this method, we call the sendPlayTime method on the game server's microservice. In our sendPlayTime methods, we have some configurations that need to be set up in our Beamable dashboard. We discussed a few of them in the previous video, and now we will focus on the service JSON. But first, to configure the service JSON, go to the Beamable dashboard, then navigate to Operate and select Config. From there, go to the Accounts section, click on the Edit button, then the plus button. Then, go to the file that you downloaded from Google Cloud, open it using a text editor, copy its content, paste it into the value field, and then enter service JSON as the key. Finally, click Save to apply the changes. Now, let's go back to the code. First, we need to make sure that the service JSON config is set up. If not, it returns an error. Then, we check if the device used by the users is whitelisted or no. Next, we check if we can call the Google Play Integrity API. And fortunately, we cannot call Google Play Integrity too often, so we add this method to call it every 30 minutes. You can adjust it based on your game's needs. Note, it's also recommended to call Google Play Integrity on your app launches. This method is responsible for verifying integrity tokens using Google Play Integrity API. The method takes two parameters: service JSON, which contain authentication information, and integrity token, the token to be verified. It retrieves Google credential from server's JSON. Make sure to create a scoped credential with the appropriate scope. Then, it constructs a JSON payload with the integrity token and sends a post request to the Google Play Integrity API endpoint. It awaits the response from the API and handles it accordingly. If the response is successful, it returns the response content. If the response is unsuccessful, it logs the error information and throws an exception. Finally, make sure to change this with your current project package name. After that, we compare the payload and the request hash. Google Play Integrity returns the hash we sent to the client. And because we also have the payload that we sent from the client side containing the game data, we recompute the hash. If the hash we recomputed here does not match the hash we get from Google Play Integrity, we can assume that the payload sent from the client to this microservice has been altered or is fake. Then we check the response data. If app integrity is not player recognized, this means the app is not genuine, possibly installed outside of Google Play or tampered with. If device integrity does not meet strong integrity, then the device has a high chance of being fake or rooted. Basically, if they fail any of these checks, we set a blacklisted item to the user. Afterward, press play on the game service microservice to ensure everything is functioning correctly. Then, publish the microservice to Beamable to enable testing on devices. Now, the final process is to build the app and upload it to Google Play Console for testing purpose. First, ensure that in your build settings, your target API level is set to at least API level 26. Then, navigate to the Google Cloud Console, proceed to the testing section, and select Internal Testing. Click on Create New Release. You may notice a warning regarding app bundles. Click on Choose Signed Key, then use Google Generated Key. Then, press Upload and find your bundle. Fill in all the necessary information about the release, click Next and Save. After that, select your testers and simply copy the link to share the app for testing. As you can see, if I try to build an APK and attempt to play the game to receive the reward, I encounter an error message. As a result, my device becomes blacklisted because it has not been verified and it fails the Google Play integrity checks due to the app not being installed from Google Play. Now, there are two ways to bypass this. The first is to upload an internal test version to the Google Play test track, as I mentioned earlier. The other way is to whitelist this user using their ID. To do this, we can navigate to Beamable, go to the Engage section and click on Players. Here we can see a list of players. We select the same user ID shown in the game, then scroll down to Inventory and click Add Item. From there, we select Whitelisted. Now, this player is whitelisted and can skip the Google Play integrity check. When we return to the app and perform the action again, such as withdrawing, we can see that it is successful and data has been sent to my Zibidi account. Thank you for watching. I hope you enjoyed this and found it useful.